All right. Do I get any kind of introduction or anything?
Yes, I can do an introduction.
All right.
I'm not the best at it. So Tyson, he's been with us from almost the beginning. He's a senior engineer, and also you've been a CTO at several companies, right?
A couple.
A couple companies. And tonight he's going to give a talk on microservices in GraphQL world. So give a big shout out to Tyson Cadenhead.
Thank you. What we're going to talk about today is kind of a big topic. So I am going to try to break it down a lot, but basically what I want to cover is how we're going to learn how to build, scale, and decouple software and software teams to reduce friction and push out more valuable features. So in a lot of ways, what I'm going to go over isn't just a technology problem, but it's also a problem of how you can scale your teams and make them more efficient and grow more. So this is the table of contents. This is going to be, I'm approaching this kind of like a book. So there will be chapters and all that stuff. So the table of contents for tonight, we're going to talk about the monolith, microservices, GraphQL, federated schemas, event-driven architecture, micro front ends, and then finally how to organize repositories. So buckle up. Before we get started, a little bit about me. My name is Tyson Cadenhead. Right now I'm a senior full stack architect at VHT, which they're pulling a Facebook right now and they're changing their name, so we'll be mindful in a few days. But right now it's called VHT. And then before that, I was the VP of engineering at Evolution Virtual, followed in the great footsteps of John Keller here. And before that, I was the CTO at Olympia, where I led the team there. And so I've also written a book, the Socket.io Cookbook, and I am a big enthusiast of serverless, GraphQL, TypeScript, React, and functional programming. I have a blog at Venable.io where I write infrequently, but I always plan on writing more than I do. But time gets away from you. So let's jump right in. Chapter 1, the monolith. So this is Jack. And before I get too far into this, I showed this presentation to my son last night. He's 8 years old, and he wanted to stay up late, so I showed him this talk. And he was like, "Jack, that's the name of our dog." So as you might know, this is Jack, my mini Bernie Doodle, and he is a lot of the names that I used for this, I just pulled from my pets and family members, so it's very unoriginal. And this is what he looks like now. He's kind of grown up a little bit. He's not a puppy anymore. But anyway, Jack, he had this idea. He was going to start this company called Widgets Incorporated. He's going to build this out, and he was the first developer on the project, so he just built out basically a basic monolith. So he had a front end, an API. They all lived in the same repository, and he was happy. Everything was good. You can see he's smiling right there, so things are going well. Well, the problem happened when he started hiring some more people to come work on the project with him. At that point, they kind of started bumping into each other. One of the developers, Tori, who I stole that name from my sister, she said, "I wish we could deploy the front end and back end independently of each other, because every time they would deploy something, they would have to wait for both the front end and back end to all spin up through CI/CD and deploy, which could take a while." Steve, he was a complainer. He said, "This code base is large and complex," and so he wanted something that was more simple and easy to understand. So what they decided to do is that they would split it up by their technologies. So they'd have a front end and an API, and there would be a front end team that worked on the front end, and there'd be an API team that worked on the API, and that worked really well until they scaled again. And at that point, they had a really big front-end team and a really big API team, and they were bumping into each other again. They had big merge conflicts all the time, and things were not going well. Steve came back and said, "This code base is large and complex." There he goes again, complaining. So what they had to do is approach everything with more microservices. So what they decided to do is build out a bunch of REST microservices. So they had, basically they figured out that their main domains were products, users, payments, integrations, and reporting. And so they built teams around each one of those microservices, and everyone was happy. They were doing great, but then they started running into some issues. Tori said, "We have to make too many requests because they were making, if they wanted to show a page with the products and the users and the payments all on the same page, they would have to request all those different APIs, and it just got it got really big. And then Felix, who's my nephew, said, we're fetching too much. So the problem there is that a lot of times, like if they wanted to get back the product, they would get back the entire product object. And sometimes with a RESTful API, you'll also nest in some of the things that go along with it. Like if there are SKUs for the product, it might come in with that. Or you can break it up into smaller things, and then you're making too many requests again. So it's kind of a circular pattern. And then Jane said, there's no way to guarantee the types on the front end. And I stole the name Jane from my cat. So what they wanted to do is kind of break things up and have types so that they could actually know on the front end that that they're getting the data that they're expecting to get in the shape they're expecting to get it. And then Rich, who works on the payments API, he's Rich because he works on the payments API. He said, I'm scared of deprecating the APIs because anytime he would make a change, he would have to make sure that all the front ends knew about it, and there was a lot of communication that had to happen there. So that brings us to chapter 3, GraphQL. So the first thing they decided they could do is basically break it up into GraphQL microservices. So they basically took all the microservices they already had, and then they made them GraphQL, which gave them type guarantees between the front end and the back end. So this is a basic GraphQL query. They're getting a product. It comes back with the ID and the name. And so they're basically, you define the shape of whatever query you want, and then it'll give it back to you. So this is the same thing coming back from the server. It just comes back as JSON. You just do a post to the GraphQL endpoint, and it gives back exactly the data you asked for in the shape you asked for it. If we took off the ID, it would just give us the name. And so there's basically 3 types of queries you can do in GraphQL. You can do queries, mutations, which are basically like if you have a REST API, you would do a post, put, or delete. And it's kind of the same thing. You just have one thing called a mutation that does any kind of change. And then you also have subscriptions, which are basically like real-time, like WebSocket, MQTT kind of stuff. So then we have a schema definition language. This lives on the server side. So this is how we define what those types are that are coming back from the client side. So here we have a product type. So we say there's a product. It has an ID, and the exclamation mark after that means it's required. And then it has a name, which is a string. It's also required. And then we have a couple of queries on here. We can get the product, and we're expecting an ID argument. And we're also able to get a list of the products, which gives us an array. And you can tell by that bracket notation that it's a list of products. And then you have resolvers, which basically are functions that tell it's the functions in the code that say if the schema is defined this way, then we'll return however we want. So these can be asynchronous functions, and you can just do anything you want to return whatever is being requested. And this is in JavaScript, but you can obviously do the same thing in any programming language. Pretty much, I don't know of any programming language in the world that you can't do GraphQL with at this point. But the question is, would you want to? And then this is the schema, which basically we put together the type definitions that we had in the resolvers, and then I'm using something called Apollo Server, which is a library that's pretty popular in the Node.js realm. And so once you do that, it's all exposed, and you can just do post to the query, and you're able to do stuff. So the question now is, once we have all this stuff, where does the routing actually happen? And the routing happens on the front end. So the front end has to know that there's a product service and a user service, a payment service, and integrations and reporting. Those all have to be known by the front end, and it has to know which ones to hit to get which things. So the problem, well, I'll get to the problem in a second there, but this is how you would do it. So you basically have client-side routing, and here I'm using Apollo client, and I'm just basically splitting whenever you add a certain context with a certain client to the query you're making, it would actually resolve to a different API. But then we get to the problem. So Tori says, we still have to make too many requests. And the reason for that is that you have to, if you want to get products, users, and payments on the same page, you actually have to request all 3 of those APIs. So they're still all split up. So what is the answer to that? The answer is federated schemas. So the first stab they would take at this is they decided that they would build a GraphQL API gateway, basically in front of a bunch of RESTful APIs. So that way they have one schema here in the middle, and it resolves to a product or a user, and basically the front end doesn't have to know about all the different APIs. It's just all available for the front end to call, and this API deals with all those things. Jane came in and said, there are no type guarantees between the REST services and the API gateway, which is true because there's no way that the API gateway knows what's going to be returned. It's just, it's a contract, it's a handshake contract, kind of. And then Steve comes in and complaining as usual. He says, why do I have to own all the schemas? Because he has to sit right there in the middle and like control all the schemas and what the type definitions are and how they're resolved to the different REST services. Well, we're tired of Steve complaining, so we fired him. He's out of here. So now that Steve is fired, we have to figure out what to do about that position he was holding. So what we're going to do is we're actually going to get rid of it entirely by creating a federated gateway where basically all the type definitions live on each of the microservices. So the product, users, and payments and integrations and reporting all have their own schemas. And they all get basically, there's a query planner that lives in the federated gateway that resolves all those different schemas together and then just gives it back. So we don't need a person in the middle anymore to control that. They're controlled in the services like they really should be. And the way we can do that is we basically have a gateway here that defines an array of subgraphs. And these are all the subgraphs that it uses to kind of merge those together. And we pass those into a super graph SDL, and it basically just works. Magic. And then we also have to, on the individual schema, the subgraph schemas that are being exposed, we actually have to wrap that in a build subgraph schema function. So it basically exposes the schema definition to be subgraphed. So the other thing is we can actually extend our types across the different subgraphs. So here we have the product, which lives in the product service. But if we want the product to be able to extend things from the user service, what we could do is we could actually add an entity, which is defined as an @ key. And it takes a field, which is like your primary key that you're telling the other graphs to identify with. And once you have that, your other graphs can come in and they can extend the type. So we do extend type and then whatever the type is. And then we have to define that same field there. And then we do an @ external to signify that that ID is coming from the product service, not the user service. And once that's available, we can just work on that type like we would usually. So like we could add a creator to the product and that could be a user. And it's actually, this is all coming from the user service. So it's completely decoupled from the products. And now for a live demo. This is where it's going to get crazy because I can't really see the tiny little print. So I'm going to blow this up. Okay, so what I have here is basically I've got a database. So I'll start this one first. And this database, I believe, is on port 3000. Yeah. Okay, so this is basically just JSON. Like it's nothing special. These are a bunch of names of people who some people claim went to the moon, and they're just available there. So we can hit them with our other GraphQL servers. So here we're going to start the astronaut service. So this will actually be a GraphQL service, and we can make a query against it. So here I could ask for the astronauts, and I get back an array of IDs and names. So this is Buzz Aldrin, ID of 1, and I can also, you can go to the docs here and see what's available. So if I wanted to get add something to it, it looks like astronaut only has an ID and name, so there's nothing else I can add to that one. But you know, if I wanted to just get back the name, for example, I could just take that off and it'll just return the name. So that's available, but it's only one schema. That's basically the one subgraph. So we'll start up another subgraph. These are the missions. And here we can basically get back an array of the missions. We have the crew members, which is how we're going to link together our astronauts to the missions. But you see here, if we look at our crew type, they are an astronaut, but they just have an ID. We don't have a name on these people, so we don't know who they are based on a name. We just know what missions they've been in and what their ID is. So what we really need is to federate these two schemas together and make a brand new schema. So we'll do that. And so this is pointing at these two schemas. One of them is on port 4001 and one's on port 4002. And now we're on port 4004. And so this schema is like our overall schema. So we were able to get a crew, and you see here I've got a name on the crew. So we should actually see the people who are on the crew. So here we have Apollo 1, and we have the actual names of the people on Apollo 1. And these are coming from the two different schemas at the same time. And you can go both ways. Like here's an astronaut. We're getting back Neil Armstrong and his mission, Apollo 11. So that's basically how all these things come together. And so you can use that kind of concept to put a bunch of subgraphs together and make one big graph. So going back here. The next thing is event-driven architecture. So at this point, we've got a pretty good API that has a good unidirectional data flow that works really well. The next thing we want to do is actually pass events around, because let's say that you create a user, and the reporting service needs to know when users are created, and we don't want to have to hit the users to do queries on the user. So what we want to do is basically have some kind of event router sitting underneath it all that we can take events off of. And this can be any kind of pub sub mechanism like a RabbitMQ or Event Bridge or whatever technology you're using. It probably has something that works well with this. But you basically take these events and you subscribe to the events on other places, and when those events come in, you can trigger them. And the place where this really comes in handy on the GraphQL side is the federated APIs don't actually support subscriptions. So we kind of have to have our own service off to the side where we can do real-time stuff. So what we could do is whenever things come into the event router, we can actually trigger the subscriptions off of the subscription service that's off to the side. So and a way that this would flow is you got your front end, it makes a change, deletes a user, the delete user event gets fired onto the event router, the undeleted user subscription is triggered, and the front end does something to respond to that. This is what a subscription looks like in GraphQL schema. It's nothing special. It's just basically like everything else, except it's a subscription instead of a query. So here's a real world example of how the technologies you might use for this kind of stuff. So here I have an Angular front end. We've got a federated API here. This could be like a Docker instance with running on EC2 with Node.js, and all these other things are basically that same thing. We have a few Postgres databases passing that stuff into the event router, and then the subscription. And the event router here is RabbitMQ. Another way we could do this, if you're on the serverless side, like I tend to be, is you use React on the front end. Then all these different services are basically just API gateways with Lambdas. And then DynamoDB, if you're into the NoSQL stuff, which is DynamoDB is kind of nice because they have event streams. As they're coming in, you can actually publish out events. So you can just publish the events that come into your database onto the event router. Here I have AWS Event Bridge listening for events. In a more complicated architecture, you might have some kind of a queuing system in between those, so you don't have to overload the system at some point. And then the subscriptions are listening off of that. So that's just a couple of ways you could do it. There's obviously tons of different technology stacks. So you definitely don't have to do it any single sort of way. Okay, now moving on. Chapter 6, microfront ends. So we've kind of applied all these concepts to the back end, but what if we could actually split up the front end in the same way? We can. So here I have basically we had all these services, but what if we wanted our teams to go full stack, and we wanted the users team to be able to control the users stuff on the front end as well as the back end? Well, a lot of times you'll have a screen that looks like this. You'll have, well, hopefully not like this, but like in the abstract, you'll have a screen that has multiple things from multiple services. So here we have our users page, and we have the profile, which is coming from the user service. We have products, which the user bought, which are coming from the product service. And we have the user payment history, which is coming from the payment service. So we need some way to have those separate, but also together. So the way we could do that is by exposing federated modules. This is a feature of Webpack where you can actually expose certain modules that you want to be able to pull into other places. And so here I'm just listing the modules I want to expose in this object called exposes. And so I have a module called list payments that's going to be available. And then in the service that's pulling it in, I have a list of remotes. So this is like the host service is pulling in the list payments, and it's pointing at the actual URL where it's available. So here it's if we're running this locally, it would be on localhost 7001. It may be somewhere else if you're running it like in production or another environment. And so then once that's all there, what you can do is you can actually just pull in your modules like you would usually. So we have here, we're importing payments from payment/list payments. And here's just a regular React module or component that we're adding there inside of there. And it just works like usual, but it's actually coming from another complete place. And we can make changes of those two services independently. So we could actually change our payments module without actually even making any kind of change or even redeploying our users module. So let's do a little demo. So here, this one will be a little more simple. It's only two things. So here I'm going to start this up. This is our remote our remote one. So if we go here and look at this, we have this button right here. It just says hello from remote, and inside of this config here, we're actually exposing the button. Can y'all see that all right, or is it okay? So we're exposing the button, and so that makes that available to be able to pull in from the other places. And so here we're going to go ahead and start up our other service, and this is pointing at a remote. It's pointing at localhost 3002 and the remote entry. And so we're able inside of this app to pull that in. So we pull in this remote button, and it's available right here. So we could actually make changes to this one. So this one. So you see right here we have this color of black. Let's change that to a beautiful blue. And you see it restarted, or it recompiled the one on the left side, which that's our remote module. So that's where the button actually lives. It didn't restart this one. It's still the same. So this updated automatically because it's got hot reload. This didn't, but if I refresh it, it's there. And so if you redeploy if you redeploy your whatever remotes are being used, you don't have to actually redeploy the actual host that's containing them. And so you can really build out your systems independently of each other in a really cohesive way. Okay, so chapter 7. This is the final chapter. This is where it all comes together. Is repository organization. And this could get heated. So now that we have our full stack teams, we've got our teams have have like, if we have a product team, they can do stuff on the front end and the back end. It's all federated across the board. So they can really work in these two areas mostly, except for, exceptions where, somebody needs to update the gateway or the event router, places like that are more shared. But Steve comes back and he says, but how do we deploy it? Wait a second, didn't we fire him? So we slap a restraining order on Steve because we don't want him hanging around our office anymore. But it is a valid question, like how are we going to deploy it? So one way we could do that is multiple repos. We could have a repo for every service. So here we have a product client, product API. We have some of our shared libraries like our component library and backend common. And these all kind of live on their own repos. And then Rich from the payments API comes in and he says, but what about PRs for features that cross multiple repos? And this is a problem a lot of times because it's like if you have a big feature that you need to touch multiple repositories in, you'll have to be like, this depends on this pull request and this depends on this pull request, and it's just this huge trail of disaster. So one way you could handle that is to just put everything in the same repo. So this is a mono repo. Basically, we just have a list of packages or services that are available, and they're all there. So every team is working in the same repo, and this works pretty well for a lot of teams. I think Google is actually using this model, so it scales, I would say. But there's also some issues with that. For one thing, you can have slower deployments because if you're actually deploying everything every time something pushes, then you're kind of back in the same place you were back when you had a repo that was all together, because you are back together. Another thing is that if you do try to only deploy the things that have changed, your CI/CD process gets more complex because you actually it's not just checking what changed, but it's making sure that those things that you expected to have changed got deployed before, and if they didn't get deployed before, then you need to make sure they deploy this time, and it can become a bit of a tangled web. And then another thing is that everyone is in the same repo, which is a good thing and a bad thing. It just depends on how much you want people working across places where they're not necessarily on that team. It could be good though, because it helps teams to have standards and stuff across the board. Another way you could handle this is multiple mono repos. So here we have our products, we have the client and the API all living in one repo. And then we have to have a couple of like shared repos, like the components and backend common, that like just don't fit in any boxes. And then we would probably have to build some kind of platform team to manage all the loose ends here, like the event router and subscriptions and everything like that. So those are basically a few different ways you could. I don't know if there's another way. That's probably it. So moving on to the epilogue. Jack is happy. Everything went really well. His team was able to scale. Everything went great. Steve is in jail. He kept bothering them, and they finally called the cops, and that's it for him. Don't be Steve. The end. Any questions?